Hello friends, welcome to our channel Knowledge Amplifier. So in my previous video I have already discussed in detail about the splitting algorithm for decision tree, right? One of the very popular machine learning algorithm for regression and classification. Now in this video I am going to discuss another approach or splitting criteria algorithm for decision tree that is based on entropy. Okay, I hope you have studied this particular entropy and information theory, all this concept in information theory and coding course, or in small we also call this ITC. Okay, in this information theory and coding course, especially if you are from electronics or communication engineering background or computer science, then I am sure you have studied this in BTech. Now this particular subject's concept is required to understand this particular video. That's why I am just telling you that if you have prerequisite knowledge, well and good, but if you don't have any prerequisite related to information theory and coding, then please go through the link given in the description box. I have already discussed some fundamentals about this which will clear your prerequisite part. Okay, now coming to our today's discussion. Before going ahead with the main part, let me just give you a quick recap. What is entropy? Entropy is measure of randomness or uncertainty. In simple words, entropy is basically nothing but average amount of information. And what is information? Information is basically reverse of probability. That means if probability is less, that means uncertainty is more. Uncertainty is more means information is more. Information is more means average information will also more. That time entropy will be more. That is, entropy is basically representing measure of randomness or uncertainty. Okay, and entropy will be maximum when probability follows uniform distribution. Okay, this also intuitively I have discussed. So if you consider this particular picture here, in this particular set, suppose there are two drugs A and B, and you are testing that which drugs works on how many people in this particular set. Suppose this drug A works on only one person, and on rest 7 persons drug B works. Okay, so the probability is not at all uniform. So here basically information is less, so average information will also less. That means entropy will be lower. For this one, 3 people drug A works, on 5 people drug B works. It is near to uniform distribution, so average uncertainty or average amount of information is more here, so entropy is high. Okay, like if you consider this one, this is completely skewed distribution. Okay, on the drug A never works on any people, on drug B works on 8 peoples. Not at all uniform distribution, just completely opposite of uniform distribution. So basically this is having least amount of uncertainty. Okay, so basically least amount of information, so least amount of average information or entropy, so entropy 0. Okay, but for here, see, this is perfectly uniform, and as you know, entropy is maximum when the probability follows uniform distribution. So entropy is maximum here, which is 1, and in maximum value of entropy can go to 1. I hope you know this property of entropy from ITC course. Okay, so the in summary way we can just have a quick recap. Lower the entropy means what? Lower average information, that means lower uncertainty, that means more probability. Okay, so lower the entropy means less uniform distribution, the purer the node. If probability is more, that means the node will be purer. Like suppose you can consider this particular one. From here you can make such prediction that drug B, probability of effectively working of drug B is more in this particular node. Okay, and see, this node is more purer than this one. Where entropy is high, that node is less purer, but where entropy is less, there you can see that this node is much purer. Okay, that is one particular class is more. Okay, that is called pure node in terms of decision tree, right? And this is basically completely pure node, we can say, because same category, all the sample belonging to this particular series belonging to same category, right? So this is what is just little bit prerequisite about entropy. Now let's directly dive into our today's discussion. So suppose we have to basically predict whether drug B or drug A works on set of people or not. So suppose there are many input features are present, okay, like this set, and basically here the output we have to predict whether drug B works or drug A works. Okay, so based on different input features we have to just test and make each time splitting and create our complete decision tree kind of if-else statement, right? So suppose there is one particular feature cholesterol and another one is sex. Okay, when we are splitting based on cholesterol high or normal, then we are getting this kind of set. So in this particular sample set, drug A works on these 3 people, where drug B works 1, 2, 3, 5 people. Okay, so 3,5 ratio in this particular set. In this particular set, drug A works on 2 people, drug B works on 4 people. Here 1, 2, 3, 4, 5, 6, 7. On 7 people basically drug B works, and drug A works on only 1 people. Here drug A works on 4 people and drug B works on 2 people. You can see that when you are splitting based on this particular input feature sex, whether male or female, that time the node is more purer. Okay, we can make prediction based on this particular splitting in a more accurate way. We can say that if the person is female, then there is a more probability that drug B will work. If the person is male, then there is a more probability that drug A will work, like that. Okay, so more predictiveness, okay, which is basically target of machine learning, is present here. And what is happening here? The nodes are less impure. Okay, less impure means less uncertainty. Okay, less uncertainty means more probability, that means entropy lower. Okay, all these things I hope you can relate, right? Now see how we can decide whether we should make our splitting based on cholesterol or based on sex. Let me discuss that. So suppose this is our data set. Okay, 14 rows are present: age, sex, BP, cholesterol and drug. These are basically, drug is my output feature and age, sex, BP, cholesterol are my input features. Okay, now first step is calculate the entropy of this overall data set. We have not splitted, we are at the parent node and we started splitting. So first step is compute the entropy of this overall data set. What is the formula of entropy? You know, minus of P by B log of P by B minus of P of A log of P of A, like this, right? So now see here, drug A candidate how much? See, 1, 2, 3, 4, 5. Okay, 5A and total 14 data sets, so 9B. Okay, because 9 plus 5 is 14, right? So 9 on 9 people drug B works, on 5 people drug A works. Now calculate the entropy. Total numbers are 14, so probability of B is 9B out of 14, so 9 by 14. So minus of 9 by 14 multiplied by log of 9 by 14 minus of P of A. Probability of A is how much? 5 by 14, because 5 candidate and total 14 data points. So 5 by 14 log of 5 by 14. Entropy is 0.940. So for our parent node, the entropy is 0.940. Now suppose you have done splitting based on cholesterol. Okay, either normal or high. Normal you are sending to left node, high you are sending to right node. Okay, now see, for normal one, how many drug A and drug B? Calculate that, and based on that you compute the entropy for this left node. Similarly for high, whatever sample data points will come, for that you compute the entropy. Okay, so see here, normal is present here, 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 here and here. Okay, now see, very carefully try to understand. Out of this normal, how many drug A present? This is drug A, and here for normal the drug A is coming, and so 2 drug A, so 2A, and B how many? 1, 2, 3, 4, 5 and 6. 6B. Okay, so now calculate the entropy for this. Simple, total 8 data points here, out of which 6 are belonging to B. So minus of 6 by 8 log 2, 6 by 8 minus of 2 by 8 log 2, 2 by 8. You will be getting this value. Okay, so entropy is 0.811. Similarly for this node, compute the entropy. See, 3B, 3A, no need to compute. This is uniform distribution, so entropy will be 1, because entropy is maximum when probability follows uniform distribution, and maximum value of entropy is 1. Okay, so now we are getting this entropy. Like this, you can compute entropy after splitting based on a particular input feature. Now suppose, how we can decide based on cholesterol we need to split, or based on BP we need to split, or based on sex we need to split, or based on age we need to split. So what we do, let us compare. So apply, what you do, blindly apply splitting on all the input feature. Try with cholesterol, try with sex, try with BP, try with age, like that, and compute the entropy for the child nodes, every case, in every situation, for every input feature. Okay, now suppose you are getting, I am just considering sex or sex and cholesterol, which one is better splitting criteria at a stage. So suppose initial entropy we have calculated 0.940, here also 0.940. When we are splitting based on sex, the left node entropy is 0.985. For male, this entropy is 0.592. When we are splitting based on cholesterol, in the left node the entropy is 0.811, and in the right node entropy is 1. Okay, now what should be the target? We should choose that particular input feature as splitting criteria when entropy is what? Decreasing much compared to our parent node. Because if entropy is decreasing, that means average information is decreasing, that is more probability or more predictiveness we can get for those nodes. Okay, so basically we have entropy after splitting, before splitting, for both input features. Okay, simply what we need to do, we need to consider that particular input feature for which overall entropy is decreased after splitting, and for which there is more decrement in entropy, that we need to consider. Okay, simple. I hope up to this you can understand. Right, now how you can consider for which case there is more decrease in entropy after splitting. So for that, what you do, see here, before splitting the entropy is 0.940. So you have to calculate like this. How I am calculating? Very simple, try to understand. Parent node entropy minus of the entropy after splitting. And how I am calculating this? This is weighted average entropy for considering both this left and right node. See what is happening. In this particular site, how many total data points? 3 plus 4, 7. Out of how much? 9 plus 5, 14. So out of 14, 7 are coming here, for which entropy is 0.985. So what I am doing, 7 by 14 multiplied by 0.985. In this side, how many total data points? 6b, 1a, 6 plus 1, 7. Out, actually in parent it was 14. So 7 by 14 multiplied by, for this node entropy is 0.592. So if you compute this, you will be getting approximately 0.151 value. So decrement in entropy after splitting based on sex criteria, using this particular formula, we are getting 0.151. Similarly, compute for this. How? Very simple. 0.940 minus of, see here how many data points present? 6 plus 2, 8. Actually there were 14. So 8 by 14 multiplied by entropy is 0.811. Okay. In this particular node, 3 plus 3, 6. 6 out of 14 data points coming. So 6 by 14 multiplied by entropy is 1. Okay. And again, if you compute this, you will be getting 0.048. Okay. So basically, parent entropy minus weighted entropy after splitting. This is how weighted values we compute, right? Okay. So now see, decrement in entropy we are getting more if we are splitting based on gender column or sex column. Okay. So basically, for this particular stage, our splitting criteria should be this gender input feature. Okay. And what is the formula we are applying here? Entropy of P, that is parent entropy, minus of summation over I equal to 1 to k. Okay. Here I is basically denoting how many childs are present. Like here 2 childs, so summation over I equal to 1 to 2 ni. That is number of elements at that particular node. Okay. Suppose consider the left node. How much? 3 plus 4, 7. Okay. By n. N is number of elements present in the parent node. Okay. That is 9 plus 5, 14. So 7 by 14 multiplied by entropy at that particular node, 0.985. Plus, then I equal to 2, it will take the value. Similarly here, I equal to 2 means this right node, 6 plus 1, 7 by 14 multiplied by entropy of this node, 0.598. So this is quite intuitive. What mathematics is working, this is completely clear picture we are getting. Okay. So as in this particular, based on sex criteria, if we split, as decrement in entropy is more, that is average information is decreasing, that is probability is increasing, that means nodes are more predictable. Okay. Right, as the nodes are more predictable, so we will be considering splitting criteria sex or gender one as better choice compared to our cholesterol. Like this, you have to basically compute the split or based on all the input features and check for which one you are getting the best decrement in entropy after comparing the parent node and child node entropy using this formula. Okay, right? So suppose for sex 1 the decrement in entropy is maximum, so we will split based on sex. Okay, so now in this particular node all are male, in this particular node all are female. We no need to check the next time for this particular nodes. If we want to split further, we no need to try with sex feature, because these are pure node with respect to this sex input feature, right? We will try with other input features maybe. Okay, like maybe cholesterol or BP or age, like that. Now here male one we no need to basically proceed further, because you can check here if the parent node we are splitting based on sex, then this is coming as pure node, so we no need to work around this particular left node further. But for this one, as this is mixed combination, so we need to proceed further with some other input feature trial, like maybe age or BP, like that, whatever present. So this is the correct way to build decision tree. Okay, the idea is quite intuitive. I need to make pure node. Pure node means less information, probability is more, okay, predictiveness is more, and less information means less average information. Less average information means lower entropy. So we need to check for, we will basically first split based on all possible input features, and we are going to choose that one for which decrement in entropy is more. Decrement in entropy, okay, like here you can see decrement in entropy is more compared to parent to child when you are splitting based on sex criteria, so we are preferring this one over cholesterol. Like this, in each stage it will work. So this is one of the very popular interview question for decision tree algorithm. I hope you have understood this, enjoyed this. If you want to know the fundamental concepts related to information theory and coding, please check the link given in the description box. Thank you.